Hey everyone, welcome back to the channel. In today's Go tutorial, we will be discussing the final collection type in Go, which is called the struct collection or the struct data type. A struct is a collection type in Go, which allows us to have values of a wide variety of types, or you can say different types within the same collection, as opposed to maps, slices, or arrays, which allow us to store values of only a single type. Logically, we often use a struct in Go to have all of the data related to a logical concept in a single place. Apart from that, structs are also Go's way of having user-defined types in our programs. So let us now try to understand more about the working of structs in Go. For that, I am back at the Go playground and I will start off by defining the struct type and then declaring variables of the type that we will just define. For our example, we will make use of a very simple struct which defines two attributes of a person, which will be name and age. So let's get started. The first thing I have to do is declare a type and then give it a name and then tell the compiler that this type is actually a struct. And then within the struct, I will declare two fields. The first one being name, which is of type string. The next one being age, which is of type integer. Now make note of the fact that there is no restriction as to the number of fields within a struct. The number of fields within the struct can start from 0 and can go on as high as possible. Next, let us quickly declare a variable of the person type. So p1 colon equal to person, and then we are going to initialize it with the literal syntax. So I say name, suppose let's just call it p1, and age, let's just have it as 25. Now notice one more thing, that we do need this comma at the end of the last field within the struct because if I remove this, it will lead to a syntax error. The next thing I'll do is quickly print this struct. So if I go ahead and run this program, we see that the value of the struct is shown here and the type is shown here as main.person, which means that the struct person belongs to the package main, and the value we have here is that name is p1 and age is 25. And how do we actually access the individual fields within a struct? Well, we use the dot operator and then give the name of the field. So p1 dot name and p1 dot name here, and then here I will say p1 dot age and p1 dot age here as well. If I go ahead and run this, we can see that the name field has a value of p1 and it is of type string, whereas the age field has a value of 25 and it is of type integer. Now, what would actually happen if I did declare a struct but I did not initialize it with any values at all? If I go ahead and run this program, we see that all of the fields within the struct are having 0 values corresponding to their data types. For example, name happens to be a blank string, whereas the age happens to be 0. I'll actually go ahead and put the fields back where they were. And now I'll show you that Go provides us with a shorter syntax for creating structs. So I could actually get rid of both of these keys, names and age. So if I run this program, what would happen? We see that we get the same result as before. The name becomes equal to p1 and the value becomes, the age becomes equal to 25. Why is that? Because when we defined the struct, the first field we declared was name and then age. So here Go is able to infer that p1 is the name and 25 is the age. But the only disadvantage of this is if I were happen to flip these two values, and then if I go ahead and run this program, I see that we get an error because now we are trying to assign a value which is of type integer into a variable which is of type string, and here we are trying to assign a value of type string into a variable which is of type integer, and so our compiler starts throwing an error. But what if I actually gave the names of the field here? So I say age is 25 and name is P1, and then I go ahead and run this program. Well, we see the result that we were getting previously because this time we specified explicitly that age is 25 and name is P1. And the named fields necessarily do not need to be in the same order as they were declared while declaring the struct type. And for that matter, you could also skip certain fields while creating a struct using the literal syntax. If I run this code, I see that since I did not specify age here, age gets a zero value within the P1 variable. And what happens if I do not specify the name? We see that this time the name variable or the name field within the P1 variable gets a zero value of an empty string. So let me just quickly put it back here, and then one more time I will run this program. Yes, and we are back to where we started from. Now, just for a minute, recall Go's naming conventions. Person is a struct which is being exported from within the main package, which means that any other package can make use of the person struct by using a syntax similar to main.person. At the same time, if we had a struct in which the first letter is a lowercase letter, then this struct will not be visible anywhere outside the main package but will be visible throughout the main package, which means that in this case the struct person will be accessible to only those programs which are within the main package or a part of the main package. Also, there is nothing stopping me from keeping the declaration of the struct within the function if I want its visibility to be restricted only within a particular function. So if I will go ahead and run this program, I see that we have the exact same results as we had when the struct person was declared outside of the main function. However, there is still one very important nuance that all of you should make note of here. So if I have a struct declared like this with a lowercase first letter, then it is visible only within the main package. And if I have a struct in which the first letter is uppercase, then it will be visible to all of the packages in our Go application. But if in those other packages I try to access the field's name and age, they will not be able to be used, which means that these fields on a variable of type struct person can be accessed only within the main package but not outside of the main package. For making them accessible even outside of the main package, we again would need to declare them with uppercase letters in the first position of the variable names. And with that change, these fields will be visible throughout our Go application by making use of the struct person or a variable of the type of struct person. So I hope these little nuances around the naming conventions of structs and the visibility of a struct and the fields within the struct are clear. And we'll actually see this in more details when we are learning about packages. The next concept we are discussing is that of an anonymous struct, which is a struct whose structure is defined on the fly and which does not have a name. Let us see an example. Suppose I declare a variable here called p2 and then I give the structure of the struct. So I say struct and then I will have only one field in this struct which will be name of type string. And then in another set of curly braces, I actually give a value to this field. So let the name be John. I can then go ahead and try to print the contents of the struct. Person. Okay, it should be capital P, although it's irrelevant for our example. Okay, so we didn't really change the variable name from P1 to P2. So let me make it P2 everywhere. And then when I go ahead and run this, well, we see that the value of P2 is again a struct having a single field, which is name, which has a value of John. And then we see the type of a struct is a struct which has a single field name of type string. As compared to here, where the type was main dot person, here we see the entire structure of a struct, signifying that the type is an anonymous struct. And here we see the value of p2 dot name is John and type is string as expected. Well, now where would you want to use something like this? Well, in most common cases, we will use such an anonymous struct when we want a certain structured data for a single time usage. Lastly, we are going to see that structs in Go are passed by value and not by reference. That means if I show you an example of this, suppose I assign P1 to P2, and then if I go ahead and run this program, we can see the values inside of the struct p1, and we can also see the values inside of the struct p2. Next, let me try to change a certain value inside of p2. So if I say p2 dot name will now be equal to say p2000 instead of p1, then if I go ahead and print the details of p1 and p2, let us see what is the output we are going to get. Okay, so the last four lines are the ones which are relevant to us. Here, after changing p2.name equal to p2000, we still see that p1 retains the name p1 and the name within p2 has been changed to p2000, which clearly signifies that if we assign one struct into another struct, then we are getting a copy of that struct and not a reference to that struct. Alright, then we are now going to recap what all other things that we just saw. We saw what is a struct data type. A struct is a data type or a collection in Go in which we can have fields of various types. How to create a struct, we saw that. How to use the values within a struct, the naming conventions and the visibility constraints on a struct. Mostly where to use a lowercase field and where to use an uppercase field. What are anonymous structs? We saw that structs without any name and whose structure is defined on the fly. And at last, we saw that structs are passed by value. Besides that, all of the code that we just saw has been updated in this GitHub repository aedorado/learningo. So make sure you do check it out from here. So if you found the content of the video helpful, please do hit the like button. If you find the content of my channel helpful, please click subscribe. You can hit the bell icon to never miss any new updates. And besides that, do tell me in the comments below how you're liking this series on Go so far. Like always, thanks a lot for watching, and I'll see you all very soon in a brand new tutorial.